Uh, Hello, good afternoon, guys. Welcome to Orijit's computer classes again. Today, our topic of discussion will be if-else statements, if-else ladder, and then we will proceed to the loops, for loop and while loop. So, first topic is if-else statements. So, before going to the discussion, let us understand uh, what do we mean by if-else. Means in general English, when we use if or if we use something after if, so basically we provide a condition after if, and then if that condition is satisfied, then for that some statement is given. Otherwise, for the other things, some other statements are given. For example, yeah, I am taking a common statement like if you study hard, then you are going to pass the exam. Otherwise, you will fail definitely. So in this statement, as you can see, like studying hard is a condition, right? if you, if that condition is fulfilled, then you are going to pass the exam. Otherwise, so if that condition is not fulfilled, in that case you will definitely fail the exam. The same goes here with the programming languages. uh, the syntax of if else statement is like this, where we provide, this is the syntax. Hold on, let me show you. If if, and then we provide some condition. This is a mandatory condition. So in programming languages, the condition can either be true or false, uh, depending upon the factors. Either it will be true or it will be false. That means we will be using relational operators and logical operators, which returns boolean values like true and false. Okay. Therefore, so for this condition, some tasks are given. Let's say task 1. Else, otherwise, if this condition becomes false, the given condition becomes false, then in that case, the task 2 will be executed. Okay. So if this condition becomes true, then task 1 will be executed. Otherwise, task 2 will be executed. So this is if else part. This is a single line if else. Okay. If else statements. For this, let us take an example. For example, suppose uh, we want to check in a program like whether a given number is an even number or an odd number. For that purpose, we can do it using if else statements. Let us check how we can do it. So let me delete all this. Now, first of all, we must take, as we are checking for a even number or an odd number, that means the number should be user given. So let us take a number from my user, from our user. So now as we are taking input from the user, so input is the keyword that we are using, and along with that, we shall be providing a message seeing which the user is going to give the input. Obviously, the user will not type anything in a blank screen. For that, we need to show some messages to the user. So for now, definitely enter a number. Okay, and now here, if we check, uh, although it is now being not shown for if we directly use a input keyword and take some input, then in that case, by default, our Python programming language takes the input as a string data type. And as we are checking for the even numbers and odd numbers, so in that case, as you can see here, the data type by default is str. Str stands for string. So therefore, we cannot use it for mathematical operations. And in order to check an even number or odd number, we definitely need to perform some mathematical operations. Therefore, we need to typecast it to some data type which will provide us the number in the number format, or better to say in integer format. Therefore, we use the int data type. We typecast it to integer data type using the int keyword. Okay. Now this will be converted typecasted to int. If we check this whole statement, it will be typecasted to int. Okay. So now let us proceed. Now, so for a number to be even, that means we know a common thing. A number is even only if it is a multiple of 2, or we can say if it is divisible by 2. So how can we check if a particular number is divisible by 2 or not? So we can just apply our common sense that if a number is divisible by 2, so obviously its remainder should be 0. On dividing by 2, if a number is divisible by 2, that number should give us the remainder 0. So therefore, for remainder, we use modulus operator. So if n modulus 2 double equal to 0, now this is a relational operator which checks the equality between two variables. And then this colon is mandatory in Python in order to show that in the next line, whatever we will be writing, along this indentation, that will be the task of if statement. Otherwise, if we type anything here, this will not be a part of if statement. Okay, this will not be a part of if statement. Therefore, we need to provide some indentation to it. The margin which is provided by default when we press enter here. When we press enter here, this is the default margin of the if statement. So we need to maintain this indentation, and along this indentation, we need to provide the tasks of this if statement. Similarly, now we are proceeding to the else. Now else will check a separate condition, that is the false portion of this condition. So therefore, we cannot type else under the task of if, right? So else will be a separate statement, and then under else, the task will be to print. Obviously, if the number is not even, so it will be an odd number. Okay, let us run this program and check what we get as output. So if we type 4, so it's printing even number. And let us say if we are typing, let's say 7, so yeah, the output is odd number. Now let us check what happens if we are printing something here. Okay, see, already some syntax errors are given because that under if statement the compiler is not able to find any task, and without any task, as if we are starting the else statement, and this else statement is not becoming a part of this if statement. Therefore these red marks are provided. A better way to understand it is also like, even for the else statement, whatever you are typing under this indentation, that will be the task of else statement. Otherwise, whatever we type here along this indentation, this will be the part of activity of our normal general program. Let's say I am printing here, print uh, general. Okay. Now let us see if we are executing it for odd number, so it's printing odd number and general. Okay. Now we are typing 6, that is an even number. So now see, it is only printing even number. Now this general is not getting printed. That means it is a statement of the else part. It is taking it as a statement of the else part because we have printed it along the indentation. However, if we type it along this indentation, okay, now let us check it for an even number also. So as you can see, it is getting the line general is getting printed even in case it, even in case this condition is getting satisfied. It is printing even number for this if statement, and general, this line will be printed in all the cases because it is the part of our general program. Okay, so let us see, check with an odd number. Yes, so this is how this has become a part of our general program. Okay, so therefore if you are, this indentation in our programming is very much mandatory. If proper indentation is not given, either you will get a syntax error or you will not get a desired output. Okay, so overall we can say this if else statement is something like this. So if this sum of this condition becomes true, this part of the if statement will be executed. Else if this is false, then the else part will be executed, and whatever be executed, let's say even if this condition is true, this will be executed, then it will not move to the else part. It will directly jump to the general other portion of your code. While even if this condition becomes false, it will execute the else statement, it will ignore this task, and then it will move to the general code. Okay, now coming to the if else ladder. if else if else ladder. So as you can understand by the term, it's a laddered if else statement. Like if one of the condition is false, then we move to some second condition, and if that second condition is false, then we move to the third condition for execution. For example, let us know the syntax first. And like it is like if, then condition 1, condition 1, and obviously a colon is required, need to maintain the indentation. Then for condition 1, task 1, okay, else if, sorry, not else if, it's elif, condition 2, task 2, else, else means this else, you can add a number of elifs here. Okay, after this you can add a number of elifs here. Let's say if I add another elif, it will not, it will also be checked. You can add a number of elifs here. Condition 3, then it's task 3. Okay, now but when you are typing else is the final step, and after this you cannot type any more ellipse. So that means your else is a default case, which means that if all of these conditions become false, then this is the final task. This should be executed or anything happens. That means if how it works, if condition 1 is true, then task 1 will be executed, and then other conditions will be ignored, means it will not be checked, it will directly move to the to your general code. Okay, let's say here at some point your general code is written. So if condition 1 becomes true, task 1 will be executed, and then it will move to your general code. Now let's say due to some parameters, user provided parameters or inputs, uh, your condition 1 becomes false, then it will move to your condition 2. It will check for your condition 2. If that becomes true, then task 2 will be executed and you will move to your general code. Again, it will move to your compiler, will check for your general code. Now, if the, I mean, this condition 3 and else will be ignored in that case. And now, if condition 2 becomes false, okay, then in that case, again, condition 3 will be checked. If that becomes true, then again, task 3 will be executed. All else will be ignored. It will move to your general code. And even if condition 3 becomes false, then it will move to the else part. Now, else is a default part. When any of these, all of these conditions become false, then this will definitely be executed. So this is the final step of your if else ladder. Getting my point? So after else, you cannot add any more ellipse. Before typing this else, you can add a number of ellipse. How the many you want. Usually, the number of ellipse you can type is the number of spaces, means usually means now it is infinite. In modern days, you can type infinite number of ellipse, so you can add a multiple conditions. This is the advantage of if else ladder. Okay, let us take an example. So let us do an example like, if we are if we want to check if a triangle is equilateral or isosceles or scalene. Okay, so that is our program. So let us take three sides. That means we need to compare the three sides of the triangle. So three sides of the triangle we should take from user. So obviously again we need to perform some mathematical operations or mathematical checking. Therefore we should accept only integer values from the user. So we're typecasting it to integer, and then as we are taking input, so input keyword input, then enter side one. Okay, then b is equal to int input enter side 2, then c is equal to int input input enter side 3. Okay, let me provide these bases. These are not mandatory, just providing it so that our code looks a little spacey. Okay, so enter side 3. Okay, now for a triangle to be equilateral, we know that all the three sides should be equal. That means we need to check whether this a and b are equal or not, or this b and also this b and c are equal or not. Now, so for checking the equality, which relational operator is used? Double equal to. Okay. So first we can check that A double equal to B. Now some of you might be thinking like we can check that if A double equal to B double equal to C, but remember this is not a correct code, because A double equal to B and B double equal to C. Actually, we can type it using pen, but it will ignore the next condition. This relational operator, in this way, we cannot use actually in any programming languages. We can use our relational operators. We can use relational operators only once, and if we want to use a combination of relational operators, then we can combine it using logical operators. So that is why the logical operators came into existence. Otherwise, we wouldn't have needed any logical operators for that. Okay, so we cannot use two or three, means more than one relational operators directly. In order to use more than one relational operators, we can combine them with logical operators. Now, in order to be an equilateral triangle, all the three sides needs to be equal. So that means we can say A should be equal to B, and so we are using and while saying, definitely we will use and in the programming language also. And B should be equal to C, and C should be equal to A. So C equal to A. Okay, right? And in fact, even if you don't check this parameter, this will means you can neglect this part that C should be equal to A, because if A is equal to B, A is same as B and B is same as C, then definitely C will be same as A. C and A will be having same values. No? So we can ignore this part. Also, you can add this part. It will create no effect in your code. Okay. So if A equal to B and B equal to C and C equal to A, we can say that the triangle is equilateral triangle. Equilateral, equilateral triangle. Okay. Now, now what should we check? If the triangle is not, let's say, if these conditions become false, then that means the triangle is not equilateral. In case the triangle is not equilateral, what are we left with? Either isosceles or scalene. So let us check for the isosceles now. So elif, elif, remember to maintain these indentations. So this is a task of if, and now elif is a separate condition. So for a triangle to be isosceles, either means any two sides should be equal. So for that, either A is equal to B, that means A equal to B, means A equal to B, or B should be equal to C, right? So or B should be equal to C, or C should be equal to A, right? So if any of this condition becomes true, that means if any of these two sides matches and the third side does not match, then it is an isosceles triangle, right? So therefore print isosceles triangle, isosceles triangle. Okay. Now else, now if both this condition becomes false, it is neither an equilateral triangle nor an isosceles triangle. So what we are left with? Only scalene triangles. So do we need to check any condition further? No, we don't need to check, because obviously it is common sense by common sense that if the triangle is not equilateral and it is neither scalene, I mean isosceles, then definitely it should be scalene, where all neither of the sides are equal. Okay, so it's a scalene triangle. Okay, how will it work? So let us discuss first, then we will check for the output. Now let us assume some values of A, B, and C. Let's say A is equal to 5, B is equal to 2, C is equal to 5. Okay, say we are checking for the first condition. Okay, so under if, so A equal to B, so 5 equal to 2. Is it true or false? 5 equal to 2. Definitely false. Now false, and we don't need to check for other conditions actually here. After and whatever is written, because if even if other conditions are true, because this condition is false, as we know, if one of the condition is false in logical AND, then it returns false. So this will not be executed. Still, I am checking it for you. So if 5 equal to 2, so that is false. And B equal to C, that means 2 equal to 5. So that is also false. And 5 C equal to A, that is 5 equal to 5, that is true. So we can say that false and false, as I have discussed in my video for logic operators in Python, that false and true using an AND operator. So if one of the parameter is false, false and false will definitely be false, and now false and true. So in using logical AND, if one of the condition is false, then it definitely returns false. So ultimately the value of all this is false. So this, the task of if will not be executed. It will check for the elif condition. So now let us check 5 equal to 2. Again false. Now we are using OR. So OR is just in a opposite sense. So if one of the condition becomes true, then it returns true. Like for AND, if one of the condition is false, then it returns false. And for OR, if either of the condition is true, then it returns true. Just reverse of AND. Okay. So if elif A equal to, that is 5 equal to 2, that is false. Okay. So or P equal to, that is 2 equal to 5, that is also false. So false or false is false. And now C equal to A, that is 5 equal to 5, that is true. Now false or true is definitely true, because if, as I said, if either of the condition is true in case of logical OR, so it returns true. Therefore, this task will be executed. Okay. So that means for these values, I should get isosceles triangle as output. Let us run and check. So enter side 1, that is 5. Then enter side 2, it is 2. Enter side 3, I take 5 again. So it is printing isosceles triangle. Very fine. Okay. Now let us check with 3, 3, 3. Let's say all the sides are 3. So 3, 3, 3. Now in this case, 3 equal to 3 for the first if it is true. Okay. Very fine. So now also B equal to C, that is 3 equal to 3, again it is true. So true and true, that means it is true. And now C equal to A, that is 3 equal to 3, that is also true. So true and true, that is again true. So this whole condition becomes true. That means the first task will be executed under if statement. So that is we should get equilateral triangle in our output. So enter side 1 3, enter side 2, that is also 3, enter side 3, that is also 3, and we are getting equilateral triangle. Okay, and let us make all the three sides different. How will it check? Now, first it will go to the if condition. So if 2 equal to 3 false, and 3 equal to 1, that is false. So false and false is false, and 1 equal to 2, that is also false. So false and false, false, false and false, false. First part is not executed. It moves to the elif condition. If a equal to, so 2 equal to 3 false, false, then b equal to c, that is 3 equal to 1, that is also false. So false or false is false. Or c equal to a, that is 1 equal to 2, that is also false. So false or false is false, again false or false is false. So therefore this is also not executed. So it is left with only one choice, that is to go to the else part. So scale in triangle will be printed. So it should print scale in triangle. So let us take 2, 3 and 1. So scale in triangle is our output. So that was all about our if else ladder. Okay. And we can use these logical operators. You need to understand very clearly before, means I suggest before coming to this video, you should watch the video for operators in Python first thoroughly, and then come to this video. It will be easier for you to understand, because uh, using if else, we will be using relational operators as well as logical operators. These are the two main things that we will be checking our conditions with, because these returns the boolean data types. And obviously for if else, we need to return boolean data types in the condition part, either true or false. As per that, our tasks will be getting executed. Okay. And in fact, for the logical operators, you don't need to think much. You can just apply your common sense and just build your code using if else. Okay. Okay. So let us proceed to the next one is like just a single if statement. Let us say, mm, this was if else statement, then it was if else ladder. So in fact, we can check a single if statement in some cases, like where we don't need any else or something, just a single if statement. So if that is true, that becomes true, then some part of your code, that task will be executed. Otherwise, it will move to your general code. It is very simple. It is nothing much. Condition and say colon, then a task, some task. Okay. This comes under your, this is just a single if statement. Okay. If, if statement. Okay. Uh, for this, I hope I don't need to give much example. Still, let us check one. Um, what example can I take for this? Um, let's say, uh, let me take some random example. Let me type something, then will come to my mind. Let's say, let me take something from user first. So, int input, enter a number. Okay. Let's say if n greater than 0, okay, then, oh, sorry, if n greater than 0, colon, print positive integer, okay, and print number game. But it was fun playing with the numbers. It was fun playing with the number. Okay, and then your general code comes. So let's say print number game. Now what happens here actually? So if user gives a number that is greater than 0, so these tasks under if will be executed, and along with this general part of the code will be definitely executed, whatever be the circumstances. And if user types a negative integer, so then these parts will not be executed. Only this number game part will be executed. And here we don't have any else part. Getting my point? If here we don't have any else part. Just if this is true, then this will be executed. If this is false, then these parts will won't be executed. It will move. In any case, either if it is true, then it will execute this task and move to your general code. If this is false, it will not proceed to these tasks and it will move to your general code. Okay. Let's say enter number. So 5. So it is printing that it is a positive integer. It was fun playing with the number, and number game is also being printed by our system. Okay. And second portion maybe like, let's say I'm typing here -10. See, so this part become false, and for that reason, it moved to the general code directly. Okay, so it was just a small concept. In some parts, while executing some code, some bigger problems, you may need a single if statement at some point of time. Okay, in fact, you can execute a number of if statements without the else statement. In that case, what happens? Like, let me show you. Using if else, what happens? Or if else ladder, in both the cases, if this condition 1 is true, then it will ignore, means task 1 will be executed. It will ignore the other conditions. It will not check for those conditions, be it true or false. It will not bother about it. Getting my point? It will not bother about it. And but in case, if you in place of this, if you execute it using individual ifs, okay, in that case what happens? Each and every condition will be checked because you're not using elif. Okay, so elif, actually elif means else if, or using simple else also means else. As we are using else, so else means that if the if condition is false, that means that in that case we will proceed to the otherwise part, right? In other cases, if the if part is true, that means we'll ignore the otherwise part. We'll just don't consider it, be it true or be it false. But when you are using individual ifs, so each and everything will be checked. Let's say I'm putting here if n less than 0, okay, print, let's say not n less than 0, if n equal to 0. Okay, print number is 0. Okay, here let me do it n greater than equal to 0. Okay, number is 0. Okay, now let's say if I type 0, so what it is going to print, now number is it is getting true here because 0 greater than or equal to, so 0 equal to 0, that is true, so positive integer, and it was fun playing with the number. And also checking for this condition, if n equal to 0, okay, the print number is 0. But if I would have used elif here, or let's say, yeah, elif here, okay, elif here, if I would have used elif here, in that case, what would have happened? If I type 0 here, see, it is no more printing that number is 0. Although this condition is true, what is happening now? If n greater than equal to 0 is already being true, so as it is true, it is executing these tasks, and as it was true, so it is not taking into consideration this elif part. It is ignoring this elif part, and directly it is proceeding after executing these tasks. Directly it is proceeding to your general code. Okay, when I was using just a if, another if statement, so it had to check both the conditions. So it is checking this condition also, executing the tasks for it, and also this condition is being checked. So that is the difference between a single if statements, and when we are using if else or if else ladder. Okay, that was all. That was enough about if else statements. Okay. Oh. Now let us move to loops, the different types of loops, and we will be practicing more examples on if else statements. Maybe in our Google Meet classes. Actually, it will get practiced as we proceed further to many more programs, many more problems. Automatically, we will be needing if else statements in a variety of places. And obviously loops, without loops we cannot go move work for a single moment. Loops are definitely an essential part of a program. So let us give our heading loops. Okay, now under loops we have two types of loops. Okay, loops. First one is for loop. For loop. Okay, and second one is our while loop. Okay, now first, actually, let us discuss this while loop part. Okay. Then we'll move to the for loop part, because for loop in Python actually has some what to say, some crucial portions to understand. In Python, actually, in for loop, we generally don't use relational operators as a condition. We are coming to that. First, let us discuss while loop. Actually, while loop is the simplest loop in Python. Okay. It is the simplest form of loop that we can think of. So let us say control V to use syntax. the general syntax of while. Okay. Now here also actually you can apply your common sense. That is, what do we mean by while? What is be actually when we use while again we provide some condition. That condition may either be true or false depending upon the factor situation. So after while, here is some condition we provide while some condition, then the task, then updation. Actually, the updation is a part of this task. I do updation, okay, and the initialization is somewhere outside the loop. Here you can say initialization. Okay, initialization. Wait, just a second. It is initialization. Initialization. Okay. So what do we mean by these terms actually? Actually, for this we need to check some example. Now, why do we need loops first of all? First, actually, we need these loops. And we let us take a very common example. Like if I ask you to print your name, actually, these very common punishments you know very well. If when you were a kid or in our childhood, we have seen some teachers or in even our parents used to give us a task that as you have not completed your task, just write that I will complete out my homework from the next day 1,000 times or 100 times. Take a piece of paper and write 100 times or 1,000 times that I will complete my homework from next day onwards. Or like when you used to learn writing, then we used to have a handwriting book where we had to like, write down that my name is, then whatever your name may be. In my case, like my name is Orijit. We had to write 100 times or 1,000 times like that. So here also, if we wouldn't have had loops, if we wouldn't have had loops, okay. So let's say print my name is Orijit. Again, print my name is Orijit. Okay, my name is Orijit. Now, being to be a little bit tricky, I can do like copy paste, Control C, Control V, Control C, Control V. So two times the lines are getting printed. Still, it is becoming very hectic for me to print 1,000 times yet in the line number 18. Okay, so I can print only 18 times in my output screen. Only 18 times it got printed, and I was unable to print it 1,000 times or 100 times. It will be terribly hectic for anyone to do this. In order to reduce that hecticness, we have these loops, the for loop and while loop. So now as we are discussing with for loop, okay. So let us take a input from user, that maybe our parents or our teacher is the user who is asking us to type our name 1,000 times. So say like we are asking the parents, asking our parents or teachers, like enter the number of times I need to write. I need to write. Okay. So they will to give a valid number here. So definitely for beginning anything, so we need to begin from line one. So let us take a variable where we can actually begin. So this is the initialization of the loop. That means the very beginning from where we are going to begin our loop. Okay. And in the same way, we can write like now this is the while loop we are starting. Here we are providing a condition that I less than equal to n. So let us see what it is going to do. Print my name. The statement that we are going to print is Orijit. Okay. And I is equal to this is the updation part where we are increasing the value of the variable. How will it work? Actually, what will happen? Let's say our parents has provided a value of n to be 1000 or 100. So say mm, if the value of n is 1000, so initially I is equal to 1. Now 1 less than is equal to 1000. The condition is true. As per relational operators, the condition is true. So it will come to the task. This is the task of the while loop. So it will print my name is Orijit and I is equal to I plus 1. I becomes 2 now. I becomes 2. Now what will happen? It will not move to your general code. It will again come back to this line. This is this is what loops are. It will again come back to this line. So now again 2 less than is equal to 1000. So that is again a true condition. Therefore, again my name is Orijit will be printed. Then again I becomes 3. I is equal to I plus 1. Then again it will move to this line. Now in this way, I will increase and at a point when I will reach 1000, again 1000 less than is equal to 1000, the condition becomes true. 1000 less than is equal to 1000, the condition becomes true. So print my name is Orijit will be again executed. Then I is equal to I plus 1, that is I is equal to 1001. 1001 less than is equal to 1000. So now it becomes false. Here the loop will stop. Now the loop will stop and it will move to your general code. So let's say I'm printing here, print the task is complete. The task is complete. Okay. Let us see what happens. So this is a part of your general code. Again, the indentation is very important here. Like here, whatever we're typing, these all are the tasks of loops. Okay. If we do I is equal to I plus 1 here, that won't be a part of the task of loop. See, already a syntax error being given as the indentation is not being maintained. So we need to type in a proper indentation. Okay, let us execute this. Let's see what happens. Okay, so it is in the indentation. So enter the number of times I need to write. So let's say 1000. Okay. So if you count here, see the 1000 times this statement has been printed. For your convenience, let me take a count. Let me also print the value of I along with this. So print my name is Orijit, comma I. Let me check what it does. Print. the number of times I need to print 1000. See, along with this, as I have printed the value of I, so this comma is actually a separator. So actually I'm printing I along with this statement. Comma will separate these two, or you rather better to say it will concatenate it with the given statement in the form of a string. So my name is Orijit 1, my name is Orijit 2, my name is Orijit 3. In this way, if you see, 1000 times it has been printed. Okay. See, the last final value is 1000. Right. So now this was all about the while loop. Okay. And now the task is complete. It has been printed. S- If I do, if I do I is equal to I plus 1 here, let me see what happens. Now I is equal to I plus 1 as per this is no more a task of this while loop. Okay. Because I have not written it under this indentation. That means, let us see what happens. See, it is running for infinite times, and actually the I of value of I remains 1, because this is being out, this I have printed out of the line, out of the indentation. Okay, out of the indentation of the while loop. As a result, what is happening? It is not getting the updation line. Therefore, value of the I remains 1, and every time 1 less than is equal to 1000 is true, and obviously then it will run for the infinite times, because it is remaining 1, I is remaining 1, and every time 1 less than 1000 the condition is matching, and hence even you see it is not moving out of this loop, it is continuously getting executed, and it will fill it up until your memory gets full. It will run till that time, until your SSD or HDD is fully occupied. Okay. So process finished with the exit code, that is some negative memory value. Then there's this hexadecimal value is the memory address. Okay. In other case, if we are printing it here, so see it is saying that it is under while I less than is equal to n, and therefore now if we write 1000, it is getting printed for a finite time. Let us see if we have printed 5. So 5 times my name is Orijit is it printed. So whatever be the value of n, it will print it as per that. Okay. So that was all about while loop. Okay. And in fact, you can perform actually what is the advantage of while loop is that even the value of I, the initialization, we can also leave it up to the user, upon the user. Let's say int input enter, from where I should start, from where I should start, right? Okay. Now say I am typing here, let's say 100 times, and the I am giving here 5. From line number 5 I should start. Okay. See, now the initialization was from 5, right? The initialization was from 5. Okay. If I type, if I type 200, and here I type 201, so guess what should the output be? So 201 less than is equal to 200. That is a false condition. So this loop will never be executed. Only the task is complete will be printed as per this, right? So let me press enter. So the task is complete. This loop is never executed. Okay. Now let us come to the for loop. Let us come to this for loop concepts. Here actually the syntax is the general syntax of a for loop in Python is syntax is for these cursors these terms for for just a second for again for so let me make it bold. Let's say a variable, for example, variable name may be I, for I in in range. Now this range concept is very important. I will be discussing it. I am printed it in italics for I in range. Okay. Here the initialization. Okay. Initialization. Okay, just a second. Yeah. So actually for I in range, okay, for I in range initialization, then the ending step, ending step, comma, and the updation, okay, colon, the task, right? Now in for loop, actually before understanding this for loop, let us understand what this range is. Actually, whatever we write in range, let's say n is equal to range, okay, 1 comma 100, okay, print n, okay, let's save it. See, range 1 comma 100 actually simply means, let me explain it with the loop itself, that will be beneficial. Actually range 1 comma 100 means 1 to 99. From 1 to this ending step minus 1 we will be going, okay. So let's say n for I in range, okay, 1 comma 100, okay, let me print it for you. Print the value of I, right? What happens? It actually prints it up to 99. So the ending step, one less than the ending step, the I actually travels each value under the inside this range, okay, and it goes to a step up to the step one less than this ending step. If in order to print all the 100 values from 1 to 100, definitely we need to print 101 up to this, then it will go from 1 to 100 up to 100. See, up to 100 it is being printed. So the same thing which we actually did using while loop can also be done using for loop, but the ending condition must be, ending step must be by plus 1. Now let us do some interesting things here. Let's say between 1 to 100, I want to print all the odd numbers. Okay. So if I want to print all the odd numbers, definitely either one way we can do that, being it is, since it is starting from 1, so odd numbers will be like 1, 3, 5, 7, 9. So it is increasing by 2. So we can set the updation of the loop to 2. So this is the updation portion. So plus 2, right? So plus 2. Therefore, we can say that this will print my odd numbers. Let me check using this run statement. So it is, let me say, yes, see, 1, 3, 5, 7, 9. All the odd numbers are being printed. Okay. Let's say if I want to print the even number, just start it from 2 because 2 is the first even number, or let us start it from 0 rather. Okay. So let's say 0 to, see, it is printing 0 to 0, 2, 4, 6, 8, and then up to 100. Okay. Or another way we can do it is under this condition, we can use an if statement, like we have not provided any updation. By default, if we don't provide any updation, it will assume the updation to be 1. Okay, it will assume the updation to be 1 by default in for loop. Whereas in case of while loop, if you don't provide any updation, the loop will run infinite times. Okay, but in case of for loop, if you are moving to the positive side, okay, from in beginning from the positive and moving to the positive side up to a finite ending step, and they you are not providing any updation, then it will by default increase by 1. Okay, that's all. So if in modulus 2 equal to 0, print I, so even numbers will be printed, colon, even numbers will be, sorry, if I modulus 2 equal to 0, because all the values will be coming under I. So if I modulus 2 equal to 0, that means print I. Let me check this code once. Yes, so it is also doing. So this is another way of implementing your code. So under this for loop, it is each I value is approaching and it is coming to this if condition. If it is getting false, this print statement will not be executed. Otherwise, the I modulus 2, that means if it is true, this print statement is getting executed. As a result, we are getting this output, right? And let us do the same task that we did using while loop, using for loop also, how we will be approaching. Before that, uh, we can visualize this for loop, this range concept in the form of a number line like thing. Let me show you. This updation doesn't necessarily mean we will be always moving to the positive direction. Means, in fact, the updation may always be increasing. That doesn't mean updation may also mean decrement. So we can start from a bigger value and we can move up to a smaller value. That is what about the loops are in both the loops, in for loop also, in while loop also. So let me make you understand number line concept. I hope actually you know this concept. I've already studied in maths this number line concepts in earlier classes. So actually what is here, we are going to have, let's say 0, then 1, here minus 1, then 1, then 2 year. In fact, in limits also, we follow this number line concept only in maths. So you must be aware of this number line concepts. That is 3. And also here, let me take some values. Okay. So up to infinity. Here also something up to infinity. And also here up to infinity. Okay. So let's say this one is 0, 0, 1. Okay. Then it's 2. Then 3. Then it's 4, and then up to infinity. Okay. Then it's -1. Then it's -2. Then it's -3. Okay. Then it's -4. So let's say actually this is what our range concept is. So let's say when we are saying that I is equal to 0, means from I in range from 0 to 1. So I initially lands in 0. Okay. And from this 4, where my code has gone, let me take it to be 4. Okay. The finite value in our number line up to the finite value. And this is 0. So actually you can assume this to be open interval, the ending portion. In open interval, actually what happens in maths? We go up to the value, up to the previous value, right? In case of open intervals in maths, so we will move up to this. I will be moving up to this I is equal to 3, right? So final value of I will be 3 in this case. Similarly, if we are starting from 3, okay, if we are starting, let's say from 4, if we are starting the loop from 4, and we are fixing the range, if we are starting from 4 and we are fixing the range up to 0, so it will move up to a range. Let me remove this. It will move up to 1. How come? Now because from we are starting from 4 and the ending value is 0, and we are decrementing it. Let me decrement the loop. So your updation becomes -1. So it will decrement by 1. So 4, then 3, then 2, then 1. Then obviously not 0, because we are providing an open interval here. And in case of open interval, if we provide an open interval to the previous part, then also it moves up to a value that is successive to that value, then up to the very next value. Okay. Therefore, let us check the output in this case. So it must be 4321, right? Let me check. Yes, it's 4321. And from 0 to 4 it is from 0 to 4. And if the updation is +1, in that case it's from 0 1 2 3. So 0 to 3. So this is the number line concept you should remember. This is actually, if you understand this number line concept, you have understood for loop. There is nothing much in for loop. Okay. And okay, now let us do the same task that we have done. We did using the while loop, using this for loop. Okay. So int input, Left with how much? Okay, we are still left with 15 minutes. Input, enter a number, right? Enter a number. So for I in range, enter number, not enter number of times I need to write. Enter number of times I need to write. Right. Okay. For I in range. Okay. Now in case of while loop, we were initializing it outside. In fact, the initialization could also be user given, right? Hey, where did my while loop syntax go? It may move somewhere outside. Okay, no issues. I'm writing it again for you. While I less than is equal to while until the some condition. Okay, then task, and then updation. So in case of while loop, you used to do the initialization outside the loop, and initialization could also be user given. In this case, the initialization is inside the for loop. Okay. So let us start from 1 and we will go up to n or n plus 1. Obviously n plus 1, because if we go up to n, then it will move up to a previous value, that is up to n minus 1. So if we make it n plus 1, it will move up to n, right? And increment by plus 1. Even actually if we don't do, then also it will be plus 1. Plus 1 is by default. So print my name is Abhijit. Okay. So let me run it. Enter number of times I need to write. Now this time 100. Okay, so let me print the value of I also. How many times we are printing it. So enter number of times I need to write 100. So yes, my name is Arijit. Up to 100 times it is getting printed. So understood. I hope you got well understood about the loops, concept of loops. Now you should practice the concept of these loops using a variety, taking a variety of values of what to say, the loop variable and the initialization and condition. You can perform actually some of the assignments I can give you. I can suggest you a website. Just go to google.com and search problems based on loops in Python. Okay, in Python actually you don't need to mention problems based on loops. Okay, so here they are saying to implement it using C program. You just implement it using the Python programming language. So the name of this website, I will be sharing it in your group. Okay, if you are having any kind of doubt, you can clarify it in my Google Meet classes. So I shall be sharing the link of this site in your group. You need to perform. It is your assignment to complete at least. Here we are having 53 problems. So at least you need to complete 20 problems from here. Any 20 problems. Okay. So we can perform a variety. In fact, the pattern printing program, the printing of natural numbers, the printing of AP and GP series, for all these things and many other things, we need loops, the for loop and the while loop. Okay. Wherever you feel like executing a task more than once, executing a particular statement or a particular task. In fact, not only we can print statements here, we can also do perform calculations under loops. That is what my point is. We can also perform calculation. Whatever you want to do repetitively, you need to use loops. Okay. In fact, we will be practicing much more problems when we will be going to other topics where we will be at each point of time, we will be needing loops and also if else statements. Okay, for if else statements also, I will be sharing with you a website in your WhatsApp group. Okay, for that you need to solve two. So that's all for today. Let me end my class here. Let's call it a day. Thank you guys for staying with me. Wish you a good day.